Okay, let's go ahead and look at this problem. We start off with the problem, and the first thing we do is divide it into two half reactions. So we have S2O8, 2 minus, yields chromate. No, yields sulfate, not chromate. Yields sulfate. And then the CrO2, 2 minus, yields chromate. So when we look at this, we'll start with the sulfur half. I have 2 sulfurs and 1 sulfur. So I start by putting a 2 to balance my sulfur. Now I have 8 oxygens, 8 oxygens. So I don't need to do anything with the oxygens. I just check for charge. I have no hydrogen on either side. 2 minus and a 4 minus. So I add 2 electrons to the left. 1 chromium, 1 chromium. 2 oxygens, 4 oxygens. So I add 2 waters to the left to give me 2 oxygens plus 2 is 4. 4 hydrogens, I add 4 hydrogen ions. Now when I look at my charge, I have a negative 2 here, a negative 2 here, so they kind of balance each other out. I have a plus 4, so I need 4 electrons. Now from here I saw people do a couple of different things. We have 4 electrons in one half and 2 electrons in the other half. So I could multiply this by 4 and multiply this by 2, but I don't need to. I just chose to multiply the first one by 2, giving me 4 electrons total. If you doubled it, you'll still have a balanced equation. It'll be double the coefficients in the others. So now multiplying that and adding them together, I have 4 electrons plus 2 S2O8, 2 minus, plus 2 waters, plus CrO2, 2 minus. I'm using the bottom reaction as is. Yields 4 SO4, 2 minus, plus CrO4, 2 minus, plus 4 hydrogen ions, plus 4 electrons. Now when I look at this, the only thing that cancels is my 4 electrons, because I had no water and no hydrogen ions in one of my half reactions. Now I have 4 hydrogen ions, so I will add 4 hydroxides to each side of the equation. My hydrogen and hydroxide on the same side become 4 waters. 2 waters on the left I can cancel. So now I have 4 hydroxides plus 2 S2O8, 2 minus, plus CrO2, 2 minus, yields 4 sulfates plus chromate plus 2 waters. And if I didn't make any mistakes when I was adding together and canceling things out, I should have a balanced equation. 4 oxygens plus 16 is 20, 22. 16 and 4 is 20 and 2 is 22. 4 hydrogens, 2 times 2, 4 hydrogens. 2 times 2 sulfurs, 4 sulfurs, 4 sulfurs. 1 chromium, 1 chromium. Negative 4 and a negative 4 is a negative 8. Negative 2 gives us negative 6. What did I do? Negative 4. 2 times negative 2 is a negative 4. Negative 4 is negative 8, negative 10. Negative 8, negative 10. It was balanced. I added wrong. So I managed to get through this and balance it. Now, how many of you had problems because you forgot to multiply the sulfur by 2? Anybody? Okay, I think that is one of the biggest mistakes I see that really leads you amok later on. If you don't start off with inspection to balance things that are not oxygen and hydrogen, you'll really get messed up later. And a lot of times that will manifest itself in a situation where you have electrons on the same side of each half reaction. So that's one good way to figure that out. Okay, any questions on balancing equations? Well, this chapter is about oxidation reduction, and we've talked about some common oxidizing and reducing agents. Acids are common oxidizing agents, and there are two types that are referred to. This is kind of a vocabulary thing. There won't be any test questions saying what is an oxidizing acid, but if you read about it, I want you to not be surprised. We call acids oxidizing or non-oxidizing. Personally, I think that's a misnomer because both of these acids do redox chemistry and both of them are oxidizing agents. So if you have an acid that is called an oxidizing acid, the anion in the acid is what's doing the work. The anion is the oxidizing agent. When we have non-oxidizing acids, they also oxidize things. But in this case, it's the hydrogen ion or the proton that is doing the oxidizing, not the anion. So that's the difference. It's just a definition, and it's something that I want you to be aware of. Common oxidizing acids are nitric and sulfuric, non-oxidizing hydrochloric and phosphoric. So that's really a definition thing, and I think it's a wrong definition. I think it's misleading.